Right, so here we have a is congruent to the multiplicative inverse of 3 plus multiplicative inverse of 5 plus multiplicative inverse of 7. Multiplicative inverse of all of that mod 11. So we basically just have to figure out what a is, basically. Like, yeah. So just figure out all this stuff. So for these you can pretty much just guess and check all of these. So because 11 is quite a small number, unlike the other one, which is 997. So 3. So if we start with 1, so because multiple inverse means you have to multiply to 1 doesn't work, so that means we just add another multiple of 11. So that'll be 12. 12 is divisible by 3, so that means it's just the multiplicative inverse of 3 is 4. So I'll write that down, 4. And you can double check, it's just 4 times 2 is 12 and minus 11, that because it's mod 11, so that's 1. Now we do the same thing for 5. Sorry. So 1, that's not divisible by 5, we add 11. 12, that's not divisible by 5, we add another 11. 23, not divisible by 5, keep going. 34, 45 is divisible by 5, so we just divide by 5, that's going to be 9. And again, you can check that 9 times 5 is going to be 1 mod 11. Finally, the last one, 7, so again, we just check through. So 1, no. 12, no. 23, no. 34, no. 45, no. 56, yes. So then 56, that's going to be 7 times 8, so we just write an 8 there. And once again, you can check that 8 is indeed the multiplicative inverse of 7 mod 11. So then we just add up all of these, which is 4 plus 9, that's 13, plus 8 is 21. We take that mod 11, that's 10. Right, so now we just have to find the multiplicative inverse of 10 mod 11, because we have another one, another one there, and then so there was actually a pretty easy way to do this, because 10 is actually congruent to -1 mod 11. It actually makes things much easier. Right, so basically it's just we have 1 actually, so 1 times -1. Actually, wait, maybe negative numbers don't work. Okay, I'll just do the same strategy as before, just so that you can see how it works. So then 10, so then we're just gonna start with 1. Alright, again, that's not true. Then 12, then 23, and you can actually just continue this. I mean, it's pretty obvious. It's just 45, 56, 67, and so on. 78, 89, and then after 89, it's actually going to be 100. So that means multiplicative inverse of 10 is 10. And actually, this is true for all numbers. So as I said, it was -1, right? So the alternative method, what you could do is -1 times -1 is equal to 1 mod 11. Alright, so that means -1 is just going to be 10, so that means 10 times 10 is also 1 mod 11, so the answer is 10. And so yeah, it's pretty easy. So yeah, you should just remember that if you're working with multiplicative inverses mod x, then x minus 1, the multiplicative inverse of that is just x minus 1, and also the multiplicative inverse of 1 is just 1. That also should be pretty obvious, but good to know. So I think I'll just do one more. So what is the largest integer less than 2010 that has a remainder of 5 when divided by 7? Remainder of 10 when divided by 11, and a remainder of 10 when divided by 13. Right, so first we can recognize because it's a remainder of 10 divided by 11 and a remainder of 10 divided by 13. That means it's also going to be a remainder of 10 when divided by 11 times 13, which is 143. So now we just have to incorporate this when it's 5. It's 5 when divided by 7. Right, so this is basically just another modular arithmetic thing. It's just worded a little bit differently with divided and remainder. Right, so again, we can kind of just guess and check this here again. So we just start with 143. Sorry, it won't be 143 because it's a remainder of 10 mod 143. So we start with 10. And we check if it has a remainder of 5 when divided by 7. That is not correct. We divide 7, that would be 3. So then we just add 143, 153. Now this is a little bit harder to check, so how you check it is because it's easy to recognize. 140 is just 7 times 20, so if you subtract that off, that'll give 13. And 13 is 6 mod 7, so that doesn't work. So again, we just added another 143, so that'll be 286. Now we try it again. So again, 286. Actually, did I do this wrong? Yep. Sorry, that should be 9. Yep. So 296. 296. When you divide that by 7, what's the remainder? Again, we used similar strategies before. So 7 times 40 is 280. That's pretty obvious, and we just subtract that off. 16 divided by 7 is 2 mod 7, 2 remainder, I mean. So then again, that doesn't work because we need 5 remainder. Now here's a quick trick here. So because we found that it was 5, actually this might not work again, I'll ignore it. So 296, I'll just keep going. 296, we're going to add another 143. Wait, I just need to do this. So it should be 4 or 3. Yeah, there should be 439. Okay, again, it's very close to 60 times 7, which is 420. That's got 19 remainder and 19 remainder. And so 19 divided by 7, that's a remainder of 5. So that's what we want. So our number is going to have to be 439 mod 7 times 11 times 13. So we have to figure that out. We already figured out 143 is 11 times 13, so we just multiply that by 7. That is not too hard. That is going to be 1001. So our number is 439 mod 1001. Now 439, it satisfies it, except that it's not the largest integer. So we're trying to find the largest integer. So that means we can add another 1001 to it. So if that would make it 1440. Now is that large we can make it? Can we make it larger? Well, no, we can't, because if we add another 1001, that'll go over the limit. So that means the answer should be 1440. Yep, there we go. So I think that's enough for today. Tell me in the comments and give the video a like if you want more of these videos. If you found this video interesting and or helpful, then also subscribe so that you get notifications for upcoming videos. And otherwise, I think I'll see you in the next video.